Well, hello guys, this is a new video, and in that video I'm going to talk about the linear differential equations. So it is one of the most important topic in differential equations, and today I'm going to talk about the Bernoulli's form also of linear differential equations. So let's talk about the linear differential equation first. So first, the thing which is you have to understand what is the format of linear differential equation. So this is nothing but the format of linear differential equation. Now first you have to know y is nothing but the dependent variable, x is nothing but the independent variable. What is p and what is q? P is nothing but the constant or the function of x. Q is also same, function of x or a constant. So this is the format, and you can easily, like, after seeing that, you can easily identify this is nothing but the linear differential equation of first order. Not first order actually, yeah, it's first order but also first degree. So however, first order first degree. Now how we can solve this kind of questions or this kind of equations? First you have to calculate the integrating factor. Integrating factor is nothing but a kind of factor or a kind of multiplier which you have to multiply with the differential equation so that you can easily solve it. Now in that case, the formula for finding out the integrating factor is something like that. Well, hopefully you can understand. We have to integrate p with respect to dx, then we have to take it at the power of e. Point to be noted, this is the formula of integrating factor which is applicable for this equation only. For this equation only, not for the all equations, After that, we have to multiply the integrating factor with the dependent variable at the left side, and at the right side we have to multiply the integrating factor with the q, which is nothing but a function of x or a function of, like, not a function of x, actually it's a function of x or a constant actually. So we have to multiply if with q, then we have to integrate the whole part with respect to dx, then we have to add a constant c. And what is c? C is nothing but indefinite integral constant. Don't forget to write, right? C is indefinite integral constant, be careful. So this is the form of, like, this is the solution procedure of linear differential equations. Now let's solve a question. What I am saying, let's solve a question so that we can easily uh, you know so let's solve this question. So first you have to understand the format. So this is dy by dx, something like same, right? Dy by dx, p into dy, sorry, p into y actually. So p is here, what? P is here 1 by x, and this is q is x, right? Now we have to find out the integrating factor first. Integrating factor, which is nothing but e to the power 1 by x dx. Now basically the integration of 1 by x is what? E to the power ln x, right? Actually mod x, but I am not taking the mod. However, so this will be x, right? Because e to the power ln x is x, right? So however, this is our integrating factor. Now we have to calculate the solution. So y into integrating factor, which is x, is equals to integration of q is x, into integrating factor, which is again x, into dx plus c. Now this is x, y is equals to what? X square. The integration of x square is what? X cube divided by 3 plus c. So this is our solution. This is our solution, final solution for this question. Well, that's okay. So hopefully you can understand how we can solve this kind of questions. Now let's talk about another question where we will face some kind of difficulties. Now in that question, something is multiplied with dy by dx, so we have to do something, right? So the first thing we will do, we will generate the format dy by dx plus this is ln y divided by x, wait, so sorry, is equals to e to the power x. Now this is 1 by y, right? I am dividing x at the left side and also at the right side, so you will get something like that. Now it is very much clear that this will be our q, and like q is what, e to the power x, and p is what, 1 by x. Now in that case 1 by y is multiplied with the differential equation, which makes something like that. It is not a linear differential equation, but still we have to convert it into a linear differential equation so that we can solve it easily. Otherwise it is too much difficult to solve it. So in that case we will take something like that. It is a very clear format. In that case, be careful, this is the format, something like dy by dx into f dash y plus p into fy is equals to q. Remember this format forever, okay? Forever, remember this format forever, because it is one of the important format. In that case we will see this kind of equation, and we have to take something like that approximation. Wait, f of y is something t, let's say t is another variable. And in that case, after taking this approximation, not approximation actually, uh, like we are taking some kind of substitution actually. So after taking that kind of substitution we will be able to do it easily. So basically in that case we have to take something like fy. You can see, if I am comparing this and this equation, then we can say that like fy is nothing but what, ln y. Look at fy, and this is n, because p is 1 by x, so ln y, right? So what will be our f dash y? It should be 1 by y, and here is f dash y, here is 1 by y. Yes, this is the format. So now we can take the substitution, which is fy is what, t. So we can say like f dash y into dy by dx with respect to x. Be careful, you are differentiating with respect to x. This will be like dt by dx. So now we can say that this part will be converted into dt by dx, and fy is what, t. So this will be plus p into t is equals to q. Now in that case, this is the format of linear differential equation with first order and first degree, and we can easily solve it. But the change is here, the dependent variable is here t, not y. So in that case we have to take that fy is equals to t. So f dash y will be dt by dx. So in that case what, our fy is what, our fy is ln y. And if we are taking ln y is equals to t, then what will be our f dash y? F dash y is nothing but 1 by y, and 1 by y will be equal to our, sorry, wait a moment, f dash y is not 1 by y actually. This will be like dy by dx, because we are differentiating with respect to x, right, is equals to dt by dx. So very nice. Now we can easily solve it. We have to replace this. So this will be our dt by dx. The final equation will be dt by dx plus fy is converted into t. So this will be our t by x plus, not plus actually, equals to q. And q is what? Q is what? We can say like, wait a moment. Q is what? Q is e to the power x. Right, q is our e to the power x. Very nice. Now we can easily solve it. In that case, the integrating factor is what? We have to find out the integrating factor first, which is e to the power integration of 1 by x dx, which is nothing but equals to x, right? Wait, what is happening? I don't know. This is x, integrating factor is x, right? You have to multiply. Now you have to multiply, wait a moment. Well, now you have to multiply the integrating factor with what? Not y. Now it is t, because t is the dependent variable now. Our equation is something like that, which is different from our primary equations, right? So t into integrating factor, which is x, is equals to q. Q is nothing but e to the power x into dx plus c. Now What is the value of t? The value of t is ln y. You can replace at the final form, but I am replacing because like it doesn't matter actually in that case. You can replace after getting the value of t at the final after doing the integration, but like doesn't matter actually, so you can easily replace at the primary form. Now basically this is integration. Well, this is our e to the power x into x, so you have to use the by parts. Now I am using a shortcut which is e to the power x into x by 1 minus 1 by 1. I am using the shortcut, so you can use the like by parts, but I am not using because I am very lazy. This is e to the power x into x minus 1 plus c. Wait, c. What is happening? Wait, I don't know what is happening, but still it's okay. So basically this is our final answer for this question. So hopefully you can understand. So hopefully you can understand how we can solve this kind of questions, right? In that question, the question is little bit difficult because in that case we have to know this format, otherwise maybe some of you will not be able to solve, but I have told you. So very nice, practice some questions, you will be able to do it very easily. Just you need to practice. So in the next video I will talk about Bernoulli's form, which is also important and which is also similar looking like that, just something little bit different. You have to know this form if you want to know the Bernoulli's form of differential equations. So let's talk about it in another video. So that is all about today's video. So goodbye.